name is Julio, and today I'm going to talk about how to enrich your API test strategies, some ideas and accelerators that you can use on your day-by-day work. I've been working for Capco since 2017, and recently I moved to the US with my family to work at Capco here. I'm from Brazil, so bom dia to everyone here. Okay, so I'm also on the social media with my YouTube channel, Spotify, Instagram, and also I teach software testing for Brazilian population, and I have more than 10,000 students. So we can catch up if you guys want to talk about testing afterwards as well, okay? This is my email, julio.lima@capco.com. Okay, so if we want to talk about REST APIs, it's pretty important to talk a little bit more about the architecture, right? Just to understand what are the challenges or pitfalls that we have when we are testing APIs. So if we are looking to a system, and inside the system, we are going to see a lot of components. These components basically will compose this big system, right? So we see some interfaces like desktop, web, mobile that are user interfaces, but we also have desktop applications, the ones that we are going to install on Windows or Mac or OS X or Linux, right? But we also have APIs. That is something that is pretty common nowadays. Companies that are specifically creating APIs for some specific problem in order to solve some specific problem, right? However, these many interfaces can connect to the system that we are going to work. So let's imagine that I have a system, and this system is basically solving a big problem in the market. That is to create rules and calculation for the cart in the e-commerce websites, right? And then I decided to create a system to this, a software to solve this problem. So I go there, I create a lot of services, repositories, clients, SQL databases, NoSQL databases, queues, and all this stuff in order to do calculations and apply some rules for carts in order to help companies that has e-commerce websites to connect to my software and do this calculus instead of to implement this from scratch, right? However, this software is with me in my company. If I want to expose this software to all the e-commerces around the world, what I'm going to do is to create an API or a group of APIs, right? This is what I'm showing to you guys on the focus that you are seeing here. That is the focus of our talk today, right? We can expose all this backend using a REST API, and this REST API will be consumed by mobile applications, desktop, web applications, or even other APIs that is going to consume my API, right? Sometimes my backend is also consuming another API that is external API. For example, let's imagine that one of you guys created a brand new way to run calculation for carts, right? That's amazing. I can maybe consume your service, so I will connect to your API and test this as well. However, what happened is that when we are talking about how to test the API that I'm focusing here now, generally what we heard people saying is how to use Postman to send a request and get a response and validate the response if the JSON object is correct, if the values are string or integer. Let's not change, let's not send the token and get a 401, or let's send a token for another user and get a 403. This is the kind of how they say test strategies or test activities that we do generally when we are testing APIs. However, the universe is bigger than just that. It's even beyond just requests and responses, right? So what I want to show you here is that in order to test an API, you need to have a broader understanding of the system. So for example, what happens if the API that is outside on the top of my backend are out? What is going to happen with my backend? What kind of answer, what kind of response I'm going to get if I send a request for my API and the other API is out? You know, what is going to happen if this API send another error, right? Another thing is, how can I accelerate the test case creation for a REST API? Or how can I validate if the new version of my API are how to say still supporting the interfaces that are consuming the API itself? You know, there's a lot of questions here, and these questions are related specifically to the ideas and accelerators that I'm bringing to you today to this conversation. So today we are going to talk about 5 items, 5 ideas / accelerators that can help you to create better tests for your REST API. Okay? So the first one is backwards compatibility, how to test it. Integration exception cases, how to simulate the other services, providing some errors, and then we can test these scenarios. How to use AI to test design on APIs, that is more an idea than a practical situation that I've been using so far. How to do REST API test coverage, and how to do JSON schema validation in an easier way. Okay, so let's talk about backwards compatibility. How it works. Basically, we are going to compare 2 swaggers. As you can see here, there is one swagger that has a post operation, and the second version of this swagger doesn't have this anymore. If I have a version of my API that has one endpoint and one operation, and the second version hasn't this anymore, it probably are going to hurt the UI that is consuming this. So how can I identify this quickly? I can install a package from NPM that is called Swagger Diff. This package called Swagger Diff can be used to compare 2 swaggers, two different versions of the swagger, and then tell me what kind of critical change was done there. As you can see here, I have 2 swaggers, the V2 and V3. V2 has the post operation. V3 doesn't have, okay? So I need to identify where this file is placed on my computer. Then I will type the command swagger-diff, and I will add the whole path, the absolute path of my first version of the swagger. It will tell swagger-diff that we have a version, and then I want to compare that with another version. So I will add the other version that is V3, okay? And as you can see here, swagger-diff will warn me saying, hey, Julio, I have a warn for you. One method was deleted, was the method post. And then if I see a warning here or an error here, I know that the new version of my API probably are going to cause a defect on a previous version of the UI or the API. Amazing, right? So for this, you can use swagger-diff. Another thing that I want to show you today is how to simulate exception cases coming from external services. Look at this. I will show you how to create a mock to simulate the exception cases coming from external services. Let's imagine that I have this operation here that is get v1 / travels, okay? This is in Portuguese here, but I'm showing this to you. Behind this method, we have a call that is doing a call to an external service. And this call to this external service is calling a real application, okay? And this real application will basically provide back to me the temperature. As you can see here, 37 degrees Celsius. This temperature is coming from this external service. However, what happened is that sometimes when I have this dependency, this API can be out or not done yet. So what I can do, I can replace that external API by a mock. And this mock, in this demo here, I'm using a mock service called Mountbank. Mountbank has an endpoint called imposters, and I can send a request to add a new fake endpoint to this mock server. So adding a new endpoint for this mock server, I can simulate any errors that I want. As you can see here, I added a error that is the error 500, and then when my API make a request to this mock, the mock responds with 500, and then my API will respond in some way. In this case, I can see that my API responded for 500, which for me as a tester, it's not the proper response. Then I can simulate other errors. For example, the server sending a response with an error 404. And then when I call from my API, look at this, my API responded with 422. And this is the proper response, you know? Every time that I depend on an external service, it's pretty difficult to reproduce errors like 404 or 500 coming from this external service. Because in the majority of time, the external services are not under our control, right? So the better way that I found to do it in an easy manner is to replace the external service by a mock server like Mountbank that is completely open source, and then you can simulate this kind of errors. Another thing that I brought to you today to talk and to discuss as ideas is how applications like ChatGPT or Bard from Google or other artificial intelligence services that allows us to communicate with them and to get some response are helping us to develop some test cases. So in this case, I asked ChatGPT to apply partition equivalence in order to identify what are the partitions that I have and the expected results that I have. Okay. So far, this is something that this kind of application are doing very well because it's so easy to identify patterns. But look at this. I asked ChatGPT to create JSON objects based on the test cases that I defined using equivalence partition. And after that, I'm going to ask ChatGPT to use these JSON objects to create test scripts using two libraries in Python, unit test and requests. As a test specialist, I need to be able to identify if ChatGPT is doing everything fine, you know? It's not just go there and prompt this. I need to know if they are doing this correct. Look at this. I asked ChatGPT, and ChatGPT started to create the test scripts to validate the test cases that we created based on the equivalence partitioning and the JSON objects that they created. However, once I asked it to create these test scripts, it was created. As you can see here, we have some test scripts to evaluate the application, right? However, what we have here is that the URL that were created is not the correct URL. So I can go there and say, hey, ChatGPT, use the proper URL. That is the URL that will be that will help me to send these requests properly, right? And I can do it as well, because it's something that is available based on the way that this artificial intelligence mechanism was created, right? So I just asked it to rewrite this, and then it was rewritten. And the last part of this demo here is basically to change the status code, because as you can see here, for the post request, it is using 200. And again, this is something that you, as the test specialist, or someone that knows a lot about the business itself or the architecture, should change and ask to change in order to have the artificial intelligence creating it to you in the proper manner, right? So now created with 201. Okay. ChatGPT and Bard from Google also do the same thing, have the same how to say features to ability to do things like that, right? So sometimes when we are talking to managers, they ask us to identify coverage, right? Test coverage. And it's so difficult when we are talking about test coverage and API tests, right? But there is a library called restats, and this library restats can create reports regarding REST API testing coverage automatically. So there is a GitHub repository, and this GitHub repository was created based on this research from Martin Lopez that basically talk about test coverage for RESTful web APIs, and basically works this way. You are going to provide a Swagger, and then you are going to run the library restat, pointing to the Swagger version in the request, in the dump of the requests and responses that you send to the application when you are testing. So every time that you send a request and you get a response, you store this in the folder dumps. And then when you run restats pointing to the dumps and to the Swagger, it will do a calculation and generate a set of reports. Look at this. I run the application and a lot of reports were created. So I can see all the coverages that are proposed by Martin Lopez. And at the end, I can see the amount of coverage that something has. For example, operation coverage. How many operations were covered by my test cases? You know, so I can see that based on the test cases that I have, 28% was covered. Amazing, right? So the last one is how to do JSON schema validation. This probably is the easier one. Let's imagine that you have a post to a specific endpoint, and the response expected has this structure, data errors and a token within the data. So what I do, I copy this example model, and then I navigate to a website that is called jasonschema.net. On the left side, I will paste what is the expected structure. And in the right side, I will have a schema that is basically a syntax that demonstrates what I would like to have on the left side. On the right side now, I will have some validations. For example, saying that the token should be a string, that the token should be under data, that errors are a sibling of data, you know? All of these things will be mentioned inside this text. So what I'm going to do is to copy this text on the right side, go to Postman, and use a snippet that is called UseTime Validator. And then I will write a command on Postman that basically is var schema receive all that that data that I copied from JSON schema.net. And then I will type this command here that is pn.expect tv4.validate. I will inform the response in JSON and the schema that I copied from JSON schema.net. And when I send the request, then you are going to see that the response will be validated against the JSON schema that was sent. And this is how you can do JSON schema validation. So how to apply all of these things in your organization? First, you need to identify which strategies of these 5 that I shared with you today can be applied to your context. Second, you need to apply this and also measure in order to understand which one can be more useful for you and for your company. And the third and last one is to learn and improve based on the results that you got. So I would like to say obrigado, that is thank you in Portuguese. And yeah, if you have questions, I'm happy to answer.